the new enrollees. Okay. Good afternoon once again. No? Okay. So I have also extended the assignment to August 9. Okay. So the assignment is due in August 9, and then we will discuss the assignment on August 10. Okay. Any questions so far? So if you're late in coming up to this session, you can just chat me, no? So I can adjust my attendance. So earlier somebody asked if attendance is graded. No, it's not part of the grade because sometimes no, it's included in the policy that of online learning policy by the university that attendance is not graded. Why am I checking your attendance? So that I will know who's still in the class or not. No, they follow, because we'll have to know who will be allowed to take the summative test at the end. No? So if you're not in the class anymore, how can you take the summative test? So that's why I'm constantly checking the attendance to know who's still in and who's no longer in. Okay, they follow, because those who are not able to attend can just email me, or yeah, email me so that I can adjust my attendance. Anyway, so this is just for me to find out if you're still in the class or not. Okay, any questions so far? No. So anyway, last meeting we discussed a very significant difference between two commands, two instructions between the analytical engine and the IAS. Okay, do you follow? Because we were trying to convert the logic behind the program for Factorial, the Factorial program of the analytical engine. Okay, it will be more convenient if we just convert it. Okay, but we have noticed that there's a difference in 1 minus 1. Let's open that. Let's look at the instruction set. The instruction set of the analytical engine. Okay. And the instruction set of the IAS. The IAS is 1950s, no? So kasi we have CB or CS. It's here, no? It's explained here, no? CB11. One will set the lever, so it will just jump back, no? Which means it will jump back if it will set the lever. And then 1 minus 4 will also do that. 1 minus 2. And the thing is, in 1 minus 1, it will not set the lever. No? So which means that it will not go back, but will terminate the loop. Okay. However, for jump plus will only jump if the value of the accumulator is non-negative. Do you follow? Non-negative. So there's a difference between in 1 minus 1, because 1 minus 1 will work. Okay. 1 minus 1 will not set, which means it will not jump anymore for the analytical engine. However, in our example, in this example, when we have 1 minus 1, it's a 0. If this were the analytical engine, this will just halt. Now proceed to the next instruction, which is a halt. Do you follow? Do you follow? Okay. We'll just remove this. Okay. So anyway, this will not jump plus. This will go to a halt. But since this is 0 is a non-negative value, in the end, it will go back to the head of the loop, which is 6L. And when it goes back there, it will multiply our final product with 0. So in the end, we will terminate, but our final product or our final answer is 0. Do you follow? So there's a big difference, because 1 minus 1 will not work for the IAS, but it will work for the analytical engine. Okay, so that's a big problem there. we cannot force the issue, which means that the logic of the factorial program in the analytical engine will never work no matter what you do, no? Because they are two different commands. Although at first glance they look like they're the same, but there's a subtle difference. They will not work in one exception, in 1 minus 1. Do you follow? So how are we going to solve this? We are going to change the logic. Okay? So programming is an art. We can do this because anyway, if this cannot be done, the IAS would not have succeeded. But the IAS computer was a very successful computer. So it can cater to a lot of programs, much more the factorial program and the summation and the average. Okay? Any questions so far? Do you follow? No? So before that, you're taking introduction to programming this semester, right? Currently also? Concurrently? Everyone? Right? Which part are you in? Are you using C++ in your programming course? No? So are you already in the repetition and looping part or still in the branching and if then else?
Python gamit namin, sir.
Okay, Python. The other class is using C++ because maybe they have a different teacher. Okay, who's your teacher there?
Si Sir Christian Bantoquillo po.
Oh, that's why you have a different teacher. So you have repetition in Python, right? Have you ano?
Ay, hindi pa po kami nakaabot doon.
Branching, if then else.
Meron na po doon
Branching.
sa yung ano po yung mga if, yung mga ganon.
So, meron ng if then else, that's called branching. So we'll have ano? It's easy to Google, no? So I've taught Django, no, for 2 semesters. So ganyan sa Python if. Okay. Then looping. Python is indented language, no? So looping. Since you haven't done looping yet, we will introduce a new topic. No? I have a slide there, looping concepts in programming. Do you follow? You might repeat this again when you study looping in Python. But anyway, looping in any language is still the same. Do you follow? Like branching in any language, no? Branching in any language is still the same. Still branching. Okay. However, the commands are different, so they may have a different syntax. Can you open this? Anyway, I'll just open this, no? You can download this, no? I have a local copy. This will introduce us. Now, the reason why I'm teaching this because we are teaching a different logic for 4th factorial. Okay? You cannot solve the 4th factorial with loop, no? Without using looping concepts, okay? Do you follow? No? Okay. Any questions so far? Let me open the slide. So this is the same slide, no? Yeah, my old one, but I think it doesn't matter if let me use my new one. Confused, yeah. Okay, it's confused. I have 2 versions, okay? Looping concepts. Okay. Okay. Looping concepts. This is a concept in programming. What is a loop in programming? A loop is a sequence of instructions that is continually repeated until a condition is reached. Do you follow? Sometimes called a repetition. Now, when do you do repetition? For example, when you compute the sum, you repeat the addition. When you compute the factorial, you repeat the multiplication. Okay. So a loop is sometimes called a repetition. Okay. Do you follow? Repetition control structures are structures in a programming language that define how loops are organized or how loops can be created. Do you follow? Before we look at the repetition control structures, let us look at the parts of a loop. When you have a loop, you have 3 parts. Now, a head, which is the start of the loop. This is the first command that is repeated within the loop. The body is the set of commands between the head and the tail, which composes the repetition, no? Which means the set of commands that are repeated. The tail is the last command that is repeated within a loop. Do you follow? So for example, we have this. This is our program for Factorial, no? In the analytical engine. So the head, okay, this may not be a complete code, no? But we have the head, which is the first repetition, and we have the tail, which is CB print 11, because it will go back 11 steps. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it will go back to the head. Do you follow? If the lever is set. Yes, no. If the lever is set, it will go back there. Okay. You follow? So this is the a looping example. We have a head, we have a tail, and all the commands in between is called the body of the loop. Okay. Any questions so far? No. So we have the head, the body, and the tail. Okay. Any questions? Looping structures. There are in general two looping structures. We have a bottom-up structure, a structure where the repetition starts from the bottom. No? The repetition starts from the bottom to the tail based on a condition. Okay, the loop terminates when the condition is not reached. For example, the analytical engine program we have is a bottom-up structure. Why? Because it repeats based on a condition at the bottom. Okay. For example, there's a first pass and then CB11, which means that it will go back, no, to the head depending on the condition at the tail. It goes from bottom upwards. Do you follow? Bottom up ito because it repeats from the bottom and goes directly to the head depending on the condition, whether it's reached or not, no? It's satisfied or not. Okay. Any questions? The second is top-down loop or top-down structure. In a top-down structure, the looping goes directly outside of the bottom based on a condition. Okay, like this, no? So this is an example, a short program with a head, store M3, which is the head, followed by a condition. If the condition is reached, it will go to a termination branch beyond the tail. Okay, remember the tail is, this is the tail. Do you follow? It will go outside of the loop beyond the tail to terminate the loop. Do you follow? If the condition is not reached, it will proceed to the body until the tail. And then in the tail, repetition is done without a condition. No? Regardless of any condition, it will just go back to the head. Do you follow? So the main difference between bottom-up and top-down loop is the location of the condition. When the condition is at the head, it's top-down. When the condition is at the bottom, it's bottom-up. Do you follow? No? Depende sa condition. Sorry, let me go back. Okay. And then another main distinction is a bottom-up structure will always have one repetition at least. Okay. One minimum repetition of the body. In a top-down structure, during the first pass, if the condition of termination is reached, there may be 0 repetitions. Do you follow? Okay. So that's one of the distinct differences. If the condition is at the top, it's a top-down loop. If the condition is at the bottom, it's a bottom-up loop. If the minimum repetitions is 1, it's a bottom-up loop. If the minimum repetitions is 0, it's a top-down loop. Do you follow? Okay, do you follow? Now, there are two types of conditions, no? One condition is condition for termination, which terminates the loop if the condition is true. If the condition is reached, it terminates the loop. Another is the condition for continuation or repetition, which repeats the loop if the condition is reached. Now, for example, in a bottom-up structure, this is a condition for continuation, because if the condition is true, the loop repeats. In a top-down loop, usually the condition is a condition for termination, because if the condition is reached, the loop is terminated. It stops the loop. Okay? Any questions so far? Now, let's go back to our, you can download
Sir,
the,
may question ako.
yes,
Ito good sa top-down loop, then yung first na jump plus 9, ay pwede like ipalaki.
sandali. Is this Aaron? Aaron ba?
Yes, sir, it's Aaron.
Slideshow. Where do we, slideshow from the current slide. Okay, where do we go back?
Itong, hindi sir, yung bago lang.
Up, down,
Yes, sir, top-down.
yes,
So, itong jump plus 9 good.
yes.
So, mag-jump lang to siya to 9 if like if negative itong store, itong nasa M3. Ito yung
Non-negative,
mean.
yes, if it's 0 above.
Wait, if it's 0 or above, mag-activate yung jump?
Yes.
Or if negative, di na siya mag-jump, like
Siya
magpatuloy
mag-jump,
lang siya.
it will go through the body.
Oh, okay.
Okay, do you follow? However,
Yes,
if
sir.
you look at jump 909, the 9 here, 0 to 19 is a halt. Right? Halt ito, right?
Mm.
So which means it terminates the loop. Do you follow? So it's a different logic. You see? It's a different logic. It's a different logic from the bottom up. But you just have to discover the logic in order to use it properly. Do you
Okay,
follow?
sir.
So iba
Yes,
yung
sir.
logic niya, di ba? Pero sanayan lang ito. As long as you have to practice. Okay? If you know the logic, you will be able to use this properly. Okay? So baligtad, no? The condition here is the other way. If the condition is reached, it will terminate. Right? You have a different way of thinking here. Because usually in the bottom-up loop, if the condition is true, we will repeat. Right? Do you follow? Now in the top-down loop, if the condition is true, we will stop. Do you follow? So different logic, okay? We will stop. Okay, but if you're used to looping, no, you can transfer the condition anywhere from top to bottom. It can be condition for termination, condition for addition, for continuation. There's always a way to manipulate conditions, okay? But we are trying to simplify our thought process here. No, maraming combinations. You can do a condition for termination at the tail if you like, no? But to make a simple process, the top-down loop will be a condition for termination at the head. Okay? The bottom-up structure will be a condition for continuation at the bottom or at the tail. Okay? They follow? Actually, as soon as you write programs, you will be able to juggle them. Especially in modern CPUs where there's a lot of conditions. Okay? There's a lot of conditions. Now, unfortunately, for the IAS, we only have one jump plus, no? And for the analytical engine, we only have one CP and one CF. But in the modern computers, we have a lot of jumps. Have I shown you that before? I'll show you that later, no? So we will change the logic because the logic never works, no? It will not work, so we will change. So actually, the program that I've shown you is a top-down program, okay? It's here, no? Let me just erase this. Let's erase this. This is the top-down version of the program that we have to rewrite because we know that this bottom-up loop does not work because jump plus doesn't behave exactly like CB. Do you follow? Kasi dito, this is our problem. 1 minus 1 will work with CB, but 1 minus 1 will not work with jump plus. Okay? So we have to reverse our logic, no? From bottom up to top down. Okay? Do you follow? Let me open our instruction set. Okay, we have this. So this is jump plus, no? This jump plus, can you see that? No? You can download this also. If it will jump if the number is a non-negative, the number in the accumulator. Okay, let's go back to this. So likewise, no, we have jump 4 to 19 because this is our first instruction. We cannot include addresses 1, 2, and 3 because these are data. These are data, okay? The first command is load negative absolute. Load absolute negative of M1. What do we mean by this? Whatever the value of M1 is, remove the sign and force negative. Okay, we will force negative M1. This is in the instruction set. No, so load negative. This is one. No, load negative of absolute. Okay, any questions? It's there in the instruction, so there's a proof. What will this mean? AC will have -4. Okay? Because M1 is 4, it will force negative, it will become -4. Do you follow? Okay. We will have add M2. M2 is 1. Okay. Our next multiplier will be on M3. Do you follow? So this means AC receives negative of M1. We have an add of M2. So what will this mean? This means what? -4 plus 1. Okay. Do you follow? -4 plus 1. So this becomes negative. AC becomes -3. So this means what AC receives. Anyway, I have it here already. Okay, ko na lang ha. Kasi mahirap mag-type. Okay. And then this is AC. AC receives AC minus M of 2. Okay. I'll have to change the, it should be 11. We have to remove the ball. I think, why is it ball? Ball. Bakit na ball? Hindi naman ball. Calibre, okay? Anyway, disregard it. I'll change it later. No? So AC received M2, so this AC becomes -3. Do you follow? And we store M3, which means M of 3 receives AC. So this is M of 3 here, so this becomes -3. What we're trying to do is to compute for the next multiplier. Okay? Present, Areza is present. Last meeting due to inconsistent net. Areza. Okay, let me check. No? Ilagay ko na lang dito, no? Ready siya. No? Okay. So we have -3 here. We compute for the next multiplier. The next multiplier is 3. We're going to multiply this with 4. Okay. So jump plus. This is now our head. Okay. Pass number 1. Jump plus 90 to 19. This is 9L, no? Do you follow? 9L. 9L is outside the tail of the loop. This is our tail. Do you follow? So 9L will terminate because this is a halt. Do you follow? Any questions? No? Okay. Do you follow? So we'll go back to this. Store empty. Jump plus. What is the value of the accumulator? Negative, diba? -3. So will we jump plus if it's a negative? Anyone? Will we jump plus? So this illustrates a condition for termination. If it's positive, we will terminate. But since it's not positive, it's a non-negative, it's negative, no? Do you follow? We will not terminate, we will enter the body. So we'll have pass number 1. Okay? Load absolute. Load absolute of M3. M3 is -3. So load absolute means the accumulator will have +3. Do you follow? Okay. Mole of M1. Remember M1 is 4. So this will have what? 3 times 4. This is already regular, no? Okay. So this will become 12. AC will become 12. And we say store M1. So M1 means M1 receives AC. So M1, this is M1, receives AC, this becomes 12. Any questions? We have computed the first partial product. 4 times 3 is 12. That's the first partial product. Okay. Do you follow? Okay. So the next thing to compute is the next multiplier, diba? It's a repetition. Compute the partial product, compute the next multiplier. So we load M3. AC receives M3. M3 is -3. Okay. We add M1. M1 is 1. So we have -3 plus 1. So what happens to the accumulator? It becomes -2. Okay. Do you follow? Sir, if it jumps to its own cell, mo break a loop. No, it's jumping to its own cell is a halt. No, because we don't have a halt program. Okay, this one is a halt. It jumps to itself. It's a halt. Okay, because we don't have a halt command. If you don't have a halt command, automatically you jump to the same address, halts the execution. Okay, because there are computers who don't have halt commands. Okay, do you follow?
Ay, sir.
Yes.
So, kahit di ka mag-loops, parang necessary na talaga na mag-jump ka sa end ng like program.
Yes,
Like, para ma-halt.
to terminate.
Okay.
Okay. Because this is the tail of the loop. Ito yung tail natin, di ba? This is the tail. Ito yung tail natin. Now take note, at the tail, we force jump. Okay? In a top-down loop, in the tail, we force jump to the head. There's no condition. You follow? There's no condition at the tail. We just force jump to the head. Balik tayo sa head. Force jump to the head, which is 5L. Jump 50 to 19, which is 5L. This is it, no? No condition. Go back to the top. So we go back to the top, pass number 2. Do you follow? So let's record this first. The final value here is 2. Okay, this is 12. 12. This is still a 1, and the last value here is a -3. Do you follow? So that we can trace. Okay. So the accumulator is -2. We say store M3, which means M3 receives the accumulator. This becomes -2. Do you follow? We just store the next multiplier. Okay. Now here is the condition for termination. Jump plus. Jump plus to the tail. End of the tail. Okay. After the tail. Jump outside the loop. Do you follow? We will jump plus if it's a plus. Is this a plus? -2. -2 is not a plus. Okay. So therefore, we will not jump plus. We'll proceed to 6L. Any questions? Okay. Okay.
This, okay, never mind, sir.
Okay. So anyway, proceed tayo because it's a negative. So load absolute M3. Now M3 is now 2. So we load absolute. This becomes 2. Mul M1. M1 is 12. So this becomes 2 times 12. Okay. This becomes, and then the store M1 makes this 12 ito, right? 2 times 12 is 12. And store M1, no, 2 times 12 is 24. I'm sorry. Okay. 2 times 12 is 24. Okay, let's go back. There's a question. There's a question from Sam Guinness. Will it jump plus if AC is greater than 0? Now, it will jump plus if it is greater than or equal to 0. Okay, do you follow? Since it's positive. But in here, AC is -2. Do you follow? Do you follow? AC is -2. So this jump plus to 9 will not jump. Yes. Do you get my point? Okay. -2 pa yung AC natin, so hindi siya mag-jump plus. Because a jump plus will only happen if the AC is 0 or above, if it's a non-negative value. Okay, so take note, we are not going to jump to 6L now, we are going to jump to 9L if the accumulator becomes positive. Okay, but the accumulator is not positive, so therefore we will just proceed here. Okay, so this is now 2 times 12 is 24. So logic, ito, no? It's a test of logic. Okay, 2 times 4, we store this to M1, so this becomes 24. Okay, we have computed the partial product. What's the next thing to do? We compute the next multiplier. Load M3. Okay, M3 now is -2, so this becomes -2. You stop me if you don't understand, no? And then we add M1. So what's M1? 1. So this becomes -2 plus 1, right? Okay, -2 plus 1 becomes -1. Do you follow? Do you follow? And then we have a jump to 5L. There's no other condition, so we are forcing jump. We are not going to proceed here. We are going to go back to 5L. So we have a third pass. Okay. Do you follow? In our third pass.
Ay, sir.
Yes.
Akala ko, sir, na mag-jump lang siya if either 0 or higher siya, sir.
Yes, but this is not a jump plus. This is a forced jump. Take note, a jump is different from a jump plus. A jump plus has a condition. A jump has no condition.
So, diretso lang siya mag-jump.
Yeah, because there's no condition, right? No condition. Jump without a condition. Remember, in a top-down loop, at the tail, there's no condition at the tail. You follow?
Ay, sir, may question ako.
Yes.
May jump minus ba?
Wala. But in the
Wala.
IPMPC, there's a jump minus.
Okay.
Okay? Unfortunately, in the IAS, there's only one jump, conditional jump. That's the problem. But you will realize that because the next computer that we'll study is a PDP-1. There's already a lot of jumps. Okay? Because this is one of the weaknesses of the IAS, the jump. No? So it's a little difficult to program because there's very limited jump. Okay? There's very limited jump. Remember, no? In the top-down loop, there's no condition at the tail. So we'll just jump. Punta tayo dito. Our accumulator is now -1. Our partial product is 24. Okay. Our decrement is 1, and this used to be -2. Okay, -2 pa rin ito, right? Oh yeah, that's correct. That's -2. Okay. Okay. So we store M3. So the accumulator we transfer to M3. This is our accumulator. So we will overwrite the -2. This now becomes -1. Okay. Now there's the critical part again. Jump plus. Okay. Jump plus. Will we jump to the tail after the tail? Will we jump? We will not jump because the accumulator is negative. Do you follow? We will not jump because the accumulator is negative. We will proceed here. Okay. Load absolute M3. So M3 is 1, -1, so we'll have 1. Okay. Mul M1. So AC receives whatever it is times M1. M of 1 is 24. So we have 1 times 24. So this becomes 24. Do you follow? No. This becomes 24. And we store M1. So we now compute we store the last partial product, which is 24. Do you follow? Naka-record ba tayo? Anyway. Yeah, we are recording, no? Okay. 24. And then we have computed this. Now we will compute the next multiplier. We load M3. M3 is -1, right? Okay, take note. This is a -1. So load M3, this becomes a -1. Okay. Any questions so far? We add M1. What happens? We have -1 plus 1. So this becomes a 0. Do you follow? Okay. Do you follow? This becomes a 0. Now we have an unconditional jump, which means we go back, force go back. Okay. We go back to the top. We will have one more pass. Okay. So this time the AC is a 0. We have a 24 here. We have a 1 and we have a -1. Do you follow? Diba? Now, store M3. So M3 will become a 0. But the accumulator is a 0. Now, we must jump plus. Will we jump? Yes, because it's no longer negative. 0 is positive. We will jump to 9L. And now in 9L, we'll just continue to jump to itself. So this is now a halt. Do you follow? So our final answer is 24. It's correct. It's not a 0. Do you follow? So, sir, if AC is greater than or equal to 20, then yes, it will jump. Okay. Sir, if jump plus 20, what do you mean N0 to 19? Hindi ko naintindihan. Can you speak out, Guinness? What do you mean by if jump plus 20? We'll go to 20. Address 20. When you say jump plus 20, you will go to line number 20. But the jump plus will not look at the line 20, but it will look at the accumulator. No? If the accumulator is positive or negative. Do you follow? Do you follow? In this case, we will jump to 9L because the accumulator is now positive. Okay, so we will halt. If AC is greater than or equal to 20, no, AC is not greater than 20 is the address where to jump. When you say jump 20, like here jump 9, jump plus 9, we will go to 9. Ito yung 9, right? And 0 to 19 means jump to the left because there could be a 9R. It follows 9L. Okay. Anyway, in our next computer, we will not have a problem because there will be no L and R. Okay. There will be no more L and R. Do you follow? Mahirap. We'll just have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Dito kasi 1L, 1R, 2L, 2R, no? Because horizontal kasi yung ano, IAS is horizontal. Okay? Any questions? So which brings us to the point that you can now solve your assignment. Okay? If you understand this, you should be able to use the same logic, no? To compute sums and averages in the IAS. Okay, so if you look at the next computer, no, it's called the PDP-1. It's in the 1960s na. 1960 na ito. The PDP-1 was first released in the 1960s. Okay. Ito yung programming manual ng PDP-1. It's like the IBM 701 also, no? Remember, IAS is 1950. 1960 ang PDP-1 by DEC. DEC, no? DEC is still there, no? Nowadays, who owns DEC? Umagal yung ating ano. Anyway, I have a local copy, I think. No? I have a local copy of the anyway, it's there, no? If you look at the jumps, no? Ito yung DEC. It's very much like, look at that, no? It's very much like the IAS, no? Only a difference in the width, no? So it has flags, no? Because it takes note of the value of the accumulator. It still has the accumulator, and it calls its register in out. It's actually like the MQ register. Do you follow? No? It also has a program counter, a memory address register. It has an instruction register. No? It has a control unit, and it has an an arithmetic logic unit. So now the buffer register also stands for the data register. In-out register is actually the register used for input and output, not to an output device, no? Like keyboards and so on and so forth. No? Because PDP-1 already has a keyboard. No? Let's look at the instruction set. Okay, nandito na yung instruction set niya. Okay. I don't think it's a jump, no, but it's a different word name, no? Instruction list. Okay. Okay. Jump to Y and save, which means Jump the accumulator. There's a jump y, no? Jump y, which means there's no longer a jump left or a jump right. Do you follow? Just jump to an address. Okay? Okay. You can skip the next instruction. Okay. And then let's look for conditional jumps. Okay, it's not, it may not be called a jump, no, but sub is subtract, no, and then yes, we jump to y and save the program counter. Okay, so that it can return. Pero meron siyang flags eh, no? It may not be a jump, but it can check the flags, no? Take the next instruction from y, jump to y. Okay. Law is load. LAC is load the accumulator. Law n is as an assignment statement, no? Meron siyang assignment statement. Set the number of the AC to a particular value. Okay. Ito na, these are the skips, no? No? SMA, skip on a minus AC, which means that it will skip if the accumulator is negative. SMA, skip on a minus AC. This is the opcode. Do you follow? SPA, okay, skip on a plus AC. Do you follow? So meron na siyang skip if is positive, skip if negative. Do you follow? SPI, skip on plus IO, which means the IO register, not the AC. Skip on 0. If AC is 0, skip. Do you follow? In the IBM PC, they have JZ, jump if 0. Okay? Including positive, no? Skip on 0. Skip on 0 flag. If there's the flag, it's a flag register, no? Is 0. It's different, no? The flag, the 0 flag is different from the AC because there's another register which stores the 0 flag. Skip on 0 overflow, which means that if the value of the AC is 0 and there's an overflow in the other register, no, because there's an MQ, there's an overflow when you divide with the remainder. Do you follow? You skip on a 0 and there's an overflow. Okay? Do you follow? No? So there are so many skips, no? Can we have an example of a skip on the, no? Let's Google that, no? Skip example on the PDP one. Si Gordon Bell yung nag-invento nito, no? But there's no, I want to know if it's going to skip by steps or skip by address, no? Kasi pwede namang skip. If it's only going to skip one, it's okay. Do you follow? If it's only going to skip one, it's still okay. It still works the same, no? We can still do a top down and a bottom up. Okay. I look at the I look at the documentation. If it's just going to skip one, there's no problem. No. I'm going to show you an example of how to do looping if you only have a skip one. Okay? Pwede namang skip one mo it's just like an if then else, okay? Do you follow? There's no skip example. Let's look for a sample PDP1, no? Okay. It should be PDP-1. Okay. Tingnan natin dito if Wikipedia has a sample code. No sample code. You have this already. PDP-1 by deck. Deck PDP-1 code. Just take this na, baka may sample siya. You just need an example, no? The inventor, no? Gordon Bell. We don't have an example, no? We have it in the manual. No, but I'll look that up, no? There's no problem if you can only skip one. We can still loop, no? Kasi pwede namang if then else, okay? A skip one is just like an if then else. It did not specify whether it's going to skip one or skip address, no? It didn't say so. Okay. Any questions so far? No. So anyway, we are not going to meet on Thursday because we am going to have an orientation and makeup class. Those who missed a lot of meetings, you are welcome to attend the makeup class. Okay. Any questions so far? I'm not going to introduce a new topic, no, anymore. Okay, so that the other batch can catch up. Okay. Do you follow? Okay. So wala na tayong skip left or rather jump right, jump left dito, no? It's okay now. So any questions so far? So you solve your
Sir,
yes.
absent ako last time, sir. So, medyo behind ako, sir. Tapos wala ko pa nakita ang video. Ilan na po ang video, sir, na-post na po ba yung YouTube video, sir, sa last meeting, sir?
Yes.
Okay,
yes.
sir.
As of
Thank you,
last
sir.
meeting, I have posted everything, no? As of last meeting, I have posted everything. Na-delay yung last meeting, but I have already posted them yesterday, okay? Because, yeah. Oh, okay. Ito na lang isang hindi, no? 29 and 28, look at that, no? Sample programs, all the three questions, the three sections are rather, no? I have already uploaded, no? All meetings, I have already uploaded them. And the fourth factorial for the IAS loop is here, no? You follow? The worksheet which I've just shown you is also here. And the looping concepts. Okay? So you can download the example yourself. Okay? Any other questions? Okay? Okay, so see you on October 10, August 10. Okay, everybody. Now, if you have been absent for a long while, you can attend the makeup classes. The schedule is there, no? In the announcement. Okay. The schedule is here in the announcement. Second part. Okay. I'm sorry I can't open because it's slowing down already. Okay. Any questions so far? Okay. See you next meeting, everyone. Everyone, thank you for coming.
Thank you, sir.
Bye, sir.
Okay,
Thank you,
now.
sir.
Okay, thank you.
Bye, sir.
Bye, sir.
Okay.